Hello, everybody. So we are starting on our second part of lines. I think we're going to have three tests on linear equations alone. And the third one, it's all building up to that third one. The third one is where we talk about word problems. So this middle one is going to be all about systems. And we're starting off with this. So a system of linear equations will be two equations when two equations are graphed in the same plane. Like this, for example. Here's negative 1/2 x minus 7, and here's 1/6 x minus 3. And the solution to a system is always the ordered pairs that are in common. And this one I hope is pretty obvious. There is only one ordered pair that is on both lines, and it is this ordered pair, which is -6, -4. So -6, -4 is the solution to this system. And just to really drive it home, when x is -6, you plug in -6 into x, you will get -4 on this equation, and you will get y equals -4 on this equation. -6 is the only x value that will produce the same y value for both of these. So that's why it is the solution. There are other possibilities. For example, this. Here's another system, -x minus 1, -x plus 3. And what do you notice about these two lines? They have the same slope. They both have the same slope of -1, which means they are parallel. That was also on the test yesterday. Hopefully you did well there. Well, if two lines are parallel, look at their y-intercepts, -1 and 3. Can you imagine what those lines look like? They're parallel and they have different y-intercepts. So when would they ever cross? They would never meet. They have no ordered pairs that are in common. No matter how hard you try, you will never get an x value that will produce the same y value for both of these. So since the solution is the ordered pairs that they have in common, these two don't have anything in common, so there's no solution. And then we have this final system. This is the last example for us today. We have -3/2 x minus 4, which I could graph y-intercept of -4, and I go down 3/2, down 3/2, etc. But then I have to graph this one too. Well, this one isn't quite in mx plus b form, so I'm just going to do one quick division, divide both sides by 2. These 2's cancel out. This becomes -3/2. This becomes -8 divided by 2, which is the exact same line. So don't even waste your time graphing this because it's already graphed here. So since the system of these two lines, which is a silly thing to say because these are really the same line, but if the solution to a system is the ordered pairs that they have in common, well, you tell me, how many ordered pairs does this line have with this line? Every single ordered pair that's on this line. And how many are on here? An infinite amount. So this is the circumstance where you have an infinite amount of solutions, an infinite amount. And don't ever say, write, or think all solutions. That's kind of a silly thing if you think about it. We're always trying to find all the solutions. So saying all solutions is not going to give you any credit. For example, what are all the solutions to this? Well, -6, -4. That is all the solutions. There happens to be only one. I don't know where the phrase all solutions snuck in to our heads, but we need to eradicate it. Infinite solutions tells more. The solution to the system has literally an infinite amount of solutions. Every ordered pair on this line is a solution. Here, there are no ordered pairs that are solutions because there's no ordered pair on this line that's also on this line. And then finally, there is one solution. There is only one ordered pair that is on this line and this line. Bear with me while I find the stop.